Hello, grade 12s. Not you as excited as I am for finance mathematics. I'm sure you are, and don't you let's make it fast. There's gonna be a time when you look back and you say there's something wrong with my voice. Well, well
You say there's something wrong with my voice.
Okay, well, let's head into some making it maths. And future value annuities is where we're at. So here's the idea. We're paying regular amounts, maybe every month or every year. So, I think we can think of this idea, let's say that at T naught, there's something there, and we're going to look at it. And then every month or whatever, so maybe at the end of the month or at the beginning of the next month, at T1, we're going to put in some value X. And then, so we're going to keep doing this. So, as I said, every month, but the idea is that we're putting in at the end of the month or at the beginning of the next month. And so we're going to do this. Dung, 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 dung. Maybe I should have had a few of these: T4, T5, T6, T7, T8, just for argument's sake. So we're putting in. And with the formula that we're going to use, you're going to put in your last amount, and then you're going to withdraw straight away. Feels a bit strange in some ways, but maybe it's you're putting in at the end of each month, as I said, and then just when you make your last payment, you withdraw. So that's our general idea. Now, there's very interesting idea of how this looks like. What am I saying? It looks like a series, or we're adding in a whole lot of stuff. So, we could look at that geometric series and we'll do that in class, not in this video. Because what's going to matter to us is there's our lovely brand new formula that we're going to use all the time. F equals x, 1 plus I to the n minus 1 over I. So we're used to most of the things here. Future, what's this going to grow to? And, the new thing is that there's this x that you're putting in every single time. I is still interest rate, n number of compounding periods, and remember I is still going to work like if it's compounded monthly, let's say it's 11% compounded monthly, and I write it like that, then we've got 0.11 over 12. So, that bit there is still going to apply to our interest rate. Okay, so just a few things to keep in mind. One, if there are things behind my head, you should somehow tell me. No, but there are some things here, and it looks like a whole lot of text, and you can read through it, but maybe, take it all in, but then read through it again once we've gone through our examples, because we're going to touch on these as we go. So when solving these, number of payments is important. Fair enough, makes sense. Read the question carefully. Is it starting immediately, 1 month's time? Because, as you'll see in one of our examples, that's going to make us think, how we tackle the question. And, there's a hint here that says, if it says starting in 1 month's time, just think of it at the end of each month. So in our timeline here, starting in 1 month's time, you could have thought of at the end of each month. And if after you've put in all your money, you want it to sit there for a little bit of time, well, basically our formula still applies. So there it is. And then we're going to, multiplied by 1 plus I. It's almost like that's our new P value. So again, I think one of the examples talks about that, but it kind of just makes intuitive sense. If you've put your money in, and let's say you're going to put it in for another 5 compounding periods, well, you've taken this amount and you've invested it for a bit longer. Okay, so enough of that. Let's run into 2 examples for this video, and then we'll do another 2 examples still today, but in the next video. So here's our formula. I've kind of got it here. Ben deposits 1,500 Rand into a savings account each month starting in 1 month's time. How much money would he have accumulated in the account after 5 years immediately after the last payment has been made? Interest is 10% per annum compounded monthly. So for this one, we don't have to draw a timeline because we're going to use our formula as it stands. It already says that it's at the end of each month, or each month starting in 1 month's time. So we're just using our formula straight up. We don't have to think of any of those hints and tips. We just need to apply our formula. So our future value equals x well, X, how much is he putting in every single month? Okay, just to make sure that we're on track still. So putting in 1,500 Rand every month, and we're going to multiply that by this nice big fraction, 1 plus I to the n minus 1 over I. And what is our interest rate? So our interest rate here is 10% per annum compounded monthly. So in other words, our interest rate is 10% compounded monthly. 10% compounded monthly. Okay, and the other part of our puzzle then is, well, and I'm just getting my calculator up here in the meantime, is, well, how long are we doing this for? Well, the question is it's 5 years, but, oh, that's what we're told. But my question to you is, how many compounding periods is that? Well, we got 5 years. It's just whenever there's 5 years, if you haven't heard David Bowie's 5 Years song, you just got to hear it because it's a beauty. So 5 years, 12 months makes 60 over there, right? 60 compounding periods. And then all that's left is to punch that into your calculator. So I'm going to do mine with you because sometimes it's worthwhile maybe just having some variables. So again, think through which of these bits is going to make more sense to you. I find it intimidating putting that whole thing. I'm going to go, 1,500 times, and then I've got a bracket and a fraction, and then there I've got 1 plus another fraction, and on the bottom you've got a fraction. Maybe you can keep track of that, but I like to kind of see everything in the screen at once. So for me, what makes sense is I'm going to put this thing here in a variable called A. So over here, I'm going to look at it and go 0,1 divided by 12. And I'm going to shift store that in A. And even maybe this is overkill, but I think I'm going to put this stuff up here in a variable called B. So if I go 1 plus A, then that I know is B. But maybe you just put that as A. Okay, so as I say, kind of working through this, you may or may not do this, but for my mind, I find this a little bit easier because now I can go, oh, that's just B to the 60. So B to the power of 60. And I'm going to subtract 1, and on the denominator, I've got A. And I get some sort of lovely answer. If I've made some sort of mistake, so as I said, taking a bit long on this first one, if I've made some sort of mistake, so I'm just going to jot this down, 116, I suppose these are round, 155,61. So let's say that our answer comes out and it's like R1 billion, then I know something's gone wrong. What I can do now is go, oh, let me just press this up button. Oh, well, whoopsie, maybe I wrote A as 1 over 1,200. All I would have to do is go, now wait a second, 1 over 120, and shift store that in A again. And now when I go up, my previous one's there, so when I press equals, it will pull the new value of A. So just going to save a little bit of time. Just useful getting your head around those variables, because now I can see this all on the screen. To my mind, more useful. And as always, genuine, honest kind of feeling. What's your feeling on those variables and how you use the variables in the calculator, which may range from, that was a whole lot of hogwash, I just bunch it in as it is written up there somewhere. I just write that into the calculator, I can manage that. Or to, I'm going to give this a go. Maybe it's a little bit of work, but just honestly, how do you feel about those variables in the calculator? Okay, so however you feel, and as always, just interested to hear your thoughts on that. Okay, so next one here we've got, and I've just got my notes here. I'll obviously do these things before. So here we've got our next story. A minibus was purchased for 241,000. Depreciation rate is at 22% per annum. Reducing balance. Cost of a new minibus increases. Okay, kind of makes sense, this story. We've got What do you reckon? A little drawing here. Look at this. There's my minibus there. It's got some wheels there. Maybe I should just stick to the videos, hey? But look at that. There should be some windows, hey? There we go. And it's got like, my minibus has got, my minibus is called MXO. What do you think? So there's my minibus. That's the old one that I'm going to trade in. And then I'm going to get a new one that's going to be fancier. So our minibus was purchased for $241. And what we need to work out is basically how much money are we going to need? Because we're going to trade it in and it's going to be worth a whole lot less. And the new minibus is going to cost a whole lot more. So if we scrolled up to the top, we've got things to do with reducing balance. And we've got things to do with, increasing growth here as well. So these two formula here, if I just copy them, I know I can just scroll down until I see that beautiful picture. There it is. So these are kind of the two things we got for reference, because our old minibus, so maybe let's just describe what we're doing here. Our old one is going to be going down. So that is going to be 241,000, 1 minus I to the n. And what's the depreciation rate? Well, 22%. It's not compounded monthly or anything like that. That depreciation rate is pretty much always just 0.22 for, I think it was 4 years time. So 4 years. So that's what our minibus is going to be worth. 241, 1 minus 0.22 to the power 4. What do you get? Do you also get 89,000 rand? Kind of a little bit scary, isn't it? That and kind of it's true for cars, unfortunately, that a lot of these types of things they lose their value quite quickly. Okay, I'm a variable person, so I'm already just going to shift store that in A in case I need it later. So I'm going to just give myself a little heads up that that's in my variable A. And for our new one, we're going to use, let's do our new one in this nice pinky color and say, well, that 241,000, the cost of the new minibus increases at 15% per annum. So here we're going to go 1 plus 0.15 over 4 years. So we can see what our fancy new minibus is going to cost. So 241,123 times 1 plus 0.15 to the power 4. And of course, you get 421,510, comma 51. I mean, there was a whole calculator. That's a little bit extreme. Well, there's what I got. That's what I was punching in the calculator. So 510, comma 51, and I'm gonna just shift store that in B. So I know that to replace it, I'm gonna take that number minus that number. Well, now because I've stored these things, not A minus B, I guess it should have been B minus A. Look how easy it is just to do that. So I think that's worthwhile, but I'm hammering that point away, aren't I? So what we need, so what does that say? Calculate the replacement. So maybe we can just say replacement cost is 304,22. Now, if you round it off along the way here and the numbers were slightly different because of the rounding off, not a worry at all. Okay, so that's part A. Part B of our question. Part B asks, a fixed amount is deposited into a sinking fund at the end of each month. So there's quite a general kind of idea that let's plan for buying that new minibus, and let's put some money away every month so that we can afford the new minibus. Starting 1 month's time, cool. So we don't have to worry about this month thing. Our formula is going to work nicely. calculate the monthly payment of interest is earned at 8.6% per annum compounded monthly. Okay, so here we're just going to use our formula, which I've got for reference here. And we've got that. And this time, what we want to get out is 332,304,22. And what we need to put in, we don't know. But we're going to, do some things here. So I'm just putting the bits of the puzzle that we've got. And our interest rate was 8.6% compounded monthly. So we know that this is over 12, this is over 12. We know that we're doing it for 4 years. 4 times 12 is 48. Okay, so what is going on top here? What is 8.6% as a decimal number? And the reason I just thought it was worthwhile pausing there is 0.086. So maybe I should have left a little bit more space there, but I just want to make sure we don't write 0.86, but 0.086, not 86%, 8.6. Okay, so then we just need to take this number here and divide it by this whole monstrosity over here, of course, with 0.086. So again, kind of up to you how you do that. Go for it. And maybe just quickly, if there's any little strategy that you're using that's going to help you do that, shout, and then I'll solve it. And yeah, maybe you can pick up a different way from me. Maybe you stick with your way, whatever it is. Okay, so solve it and just jot down if there's anything that's kind of helpful and you're doing that on your calculator. Okay, so let me do it my way. No Sinatra net references here. Okay, so I need to go that thing divided by that whole thing. I could tip in times and go, so it's that times that thing reversed. So that, I could tip in times if I wanted to. Or you can just start working your way here and go, well, I'm going to put this in A. So this is my strategy. 0.086 divided by 12. I'm going to put that in A. I'm going to put 1 plus A, because that's what that is. And I'm going to put that in B. So I know that this thing on the right-hand side is a fraction that is B to the power of 48 minus 1 over alpha A. So that's 57. So I want to take that and divide it by that. Now that certainly doesn't seem right, so I need to pause and just check where did I make my mistake, because that divided by this is not going to give me what I want. So let's go and see. Can you see where did I end up going wrong? 0.086 divided by 12 is in A. That's that part there. 1 plus A, that should be in B. And I think it's worthwhile just seeing B to the 48 minus 1 over A gives us 57, thing. And then we're going to go, let's just shift store that in C in case we need it. 332,304, I could have stored that in a variable earlier, divided by C gives us, maybe that is about right. It's quite something that these numbers are so big. 5824,92. So that's what X is. That's quite something in some ways. Putting away almost 6,000 every month for 4 years. But that's just to wrap this up. That's what we need to be thinking when you're thinking of money and businesses and that. And obviously these examples don't include all the complex details involved, but it's a worthwhile idea to have in mind. Maybe that's what's nice about finance mathematics. Anyway, go and make it maths, and I'll see you in the next one for the other 2 examples.